Okay, let's now talk about a problem from electromagnetic theory from magnetostatic boundary condition, which I have discussed in the last video. If you have not watched that video, you can watch this video. The link can be found in the description or in the first comment. So the problem states like this: the magnetic induction in a vacuum at a plane surface of uniform isotropic magnetic material is equal to B. The vector B forms an angle alpha with the normal to the surface. Okay, so let's consider the uniform isotropic magnetic material. This is the uniform isotropic magnetic material, and this is your vacuum. This is the material. Okay, the vector B forms an angle alpha with the normal to the surface. So let's say this is the normal to the surface, n cap. Let's say, and vector B is making an angle alpha with the normal to the surface. The relative permeability of the magnetic material is equals to mu. You know the formula of relative permeability, mu r is equals to mu by mu naught, and in the question it is given mu. So instead of taking mu, here we are writing mu prime. This is equals to mu. This is the absolute permeability. Therefore, mu prime would be mu into mu naught. Here this mu prime is the permeability of this medium. Now what we have to find out? We have to basically find out the components of B prime. B prime will have components, parallel component, and B prime will have perpendicular component. So if you want to calculate the magnitude of B prime, then magnitude of B prime will be square root of B parallel prime square plus B perpendicular prime square. Now these parallel perpendicular components of B prime can be found out using magnetostatic boundary condition. This is the field B here. So let's say this is medium 1 and this is medium 2. Medium 2 is having the permeability mu prime. Now once you consider B, it will have parallel and perpendicular component. Okay, parallel and perpendicular component. What is this perpendicular component? B perpendicular here is B cos alpha. Okay, and parallel component is B sin alpha, parallel to this, right? So from this we know that perpendicular components are continuous in case of magnetostatic boundary condition. From magnetostatic boundary condition we get B1 perpendicular is equals to B2 perpendicular. So B1 perpendicular is B cos alpha. So B prime perpendicular is equals to B cos alpha. This is straightforward. What you need to find out more? You need to find out B parallel. So there is no surface current given here. So we can write H1 parallel is equals to H2 parallel. H equals to B by mu. So H1 parallel is equals to B1 parallel by mu naught, because this is vacuum, so permeability is mu naught here. But for H2 here, this is B prime parallel divided by mu prime. Mu prime is the magnetic permeability. Hence, what you can write here, B1 parallel is equals to B sin alpha. So B sin alpha divided by mu naught. This is B prime parallel. Mu prime is equals to, we have got mu into mu naught. So let's put that value mu into mu naught. This mu naught and this mu naught is getting cancelled. So from that we can easily calculate. I am writing it here. B prime parallel is equals to mu B sin alpha. Now we have got both the components, parallel and perpendicular. It is the time to add them up to get the actual value or the magnitude. So B prime is equals to square root of B parallel square, so mu B sin alpha, mu B sin alpha whole square, plus perpendicular is B cos alpha, so B square cos square alpha, B cos alpha whole square. This B thing can be taken outside, and root over mu square into sin square alpha is 1 minus cos square alpha, and this cos square alpha is remaining. So B into, so you can see this mu square and mu square cos square alpha plus cos square alpha. So we can keep mu square alone here, mu square plus this 1 minus mu square cos square alpha. Is there any option matching with it? Yes, it is matching with option D. So option D is the correct option for this question. I hope you understood this problem. If any confusion arises, you can let me know in the comment section, and if you're new to this channel, please subscribe to the channel and don't forget to press the bell icon. Finally, thanks for watching. Unacademy is India's one of the largest teaching learning platform. You can prepare for various competitive exams like CSR, NET, GATE, JEST, IIT, JAM, TFR, etc. Especially if you are preparing for CSR, NET, Physical Science, you can join me on Unacademy Plus. You can utilize our referral code PhysicsHub for getting the maximum benefits while taking the subscription. One subscription will allow you to watch the live and recorded classes of all educators of all time, including me. You will get all the 9 units covered under physical science categories for CSR NET examination. To take the Unacademy Plus subscription today and put your feet one step ahead towards reaching a goal. Thank you.